So last time we managed to use runtime type information to map our native type, and we were able to create one and destroy one from a Lua script, which is what this sprite new is doing here. We're just creating a sprite. We don't do anything with it. We just create a local for it, and then it just gets thrown away at the end of the script. And our sprite is just this really basic thing which we've registered with the runtime type information. This time I want to be able to get it so that we can at least try and invoke one of these methods. We have a move and a draw method, which is this one and this one. I'll try and invoke the draw one first because that's our example with no return types and no parameters. So we want to get to the point where we can at least invoke that without its parameters and not read any return types and just get that working. So to start with, I'll just put in the, this is would have been our script loaded from a file. I'll just put into the script exactly what it is we want to try and get. So we want to get that draw call to work. And at the moment, there's nothing mapped for that, so it's not going to work. But let's just see what it does. So yeah, attempt to index a sprite underscore empty. So empty is our meta table local value sprite. So it's looking in the meta table for the draw function, and it's not finding one, and it's not finding anything to call, which we're trying to call a function on here. So it's all going wrong. But that's a good start because it shows us at least what we've got to do. So down here, if I can find it, where we start our bindings, after we create the Lua state, we loop around all the types that we've registered. And here's where we create our new method, which is our special one, which can create our user datum for us. So that can create the sprite or any type now. That's where we make our meta table, and you can see the only meta method that we've handled is the garbage collect meta method. So I'm going to do this slightly differently to the way we did it in the previous video, but this time I'm just going to use to call the method and to get properties. I'm just going to use the index meta method. I'm not going to like register any other methods onto this Lua object, if you know what I mean. So the meta table's on the stack there, on the Lua stack, and then we push on the garbage collect method, and that pops all this stuff off and just leaves us with a meta table again. So we can just go again here and put more stuff on. So let's do the index meta method, because remember that's index is what gets invoked on. That's the meta method that gets invoked when we're trying to read something from in this case the user datum, but it's not there. So we're trying to read something, or we're trying to invoke a method which is saying, okay, where's the draw that I need? And draw's not there, so it goes to the index meta method, and we need this to return a function that it can call. So that's the goal we want to get to. So we need to push on, for our index meta method, we need to push on a C, well, we need a C function, but we're going to push it on as a closure because I'm going to need some up values for it. So I'm just going to call this index user datum, because that's what it does. It's the index method for any user datum now, not just a specific one like we had previously. And it has 0 up values at the moment, but we're going to change that. And then we set that on the meta table. So the meta table's at -1, -2, and it's there on the stack, which is -3. You can see it's being made up here. So we can keep doing this with just this pattern here where we're pushing on a function, push on another one, and we can do the same thing for new index later on. But we do need we need to know the type information that we're getting the index for. So in this case, it's this class to register. Now, here's a bit of a problem. We're looping around all the classes, and I'm setting a global using the name, but I'm also pushing in the address of that class that's being sent as a closure to the create function. But I've realized later on that I can't do this. It's actually worked in our case, but this is a bug because the address of this can actually change. So we need to fix this bug, but I'm not going to do that right now because that code's currently working. But what I am going to do is, you see this here, which gets the name of the type. I think in this RTTR library, the only way to get back the type reliably is to pass in the name and then get it by name. If you're using a different runtime type library, that might be different for you. You just need a way of recovering the type information when the Lua function is called. So in this case, I believe the only reliable way is to push on the name. So yeah, keep in mind that up there where we're pushing on the address of this would be a better way of doing it, because the address is just much quicker. We don't have to go through like a string compare or anything like that. But unfortunately, I can't find a way to recover that reliably from the address. So we'll do it this way, and then we'll fix the bug later on. So I'm going to push a string on. So this is going to be the. In fact, let's just put it on the stack up here. Need to not do this like this. Let's just make it clearer what this is. This is the type name. And well, that's the string, which is the type name. And because I'm going to use this again later on when I fix the bug. So the type name is this. Get rid of a lot. So that's what I want to push on to the stack. That makes it so I've done it like that. Instead, I could have written a comment there to say type name, but it's much clearer if you like write out the code, give it a name, and then use it like that there. So pushing the string type name shows me I'm pushing the string type name. I shouldn't be writing comments to say that. And then I need to tell it it has one up value. So that's going to give me an index user datum function that can be called whenever something's missing from the table and we're trying to read it. And it will have as an up value the name of the type that we're interested in. So we need to make that method now, don't we? So let's make that method up here. So that you can see there's our destroy and there's our create, and that's the code that needs to change here. Where is it this one? Yeah, where we're pulling out the address of this type. We can't do that. So I'll change that later on. But for now, because it's working, I'm going to leave it. But I know for a fact it won't work in all situations. It's the first time in this tutorial series really had a proper bug that spanned some of the episodes. So it means that we've actually got bugs to go back and fix from a previous one. So index user datum. So what we need to do first is recover the name of the type. So that's in our up value, remember. So there's only one up value and it's indexed from 1. So that is a string, a C string. So we've recovered the type name, and from that we can recover the type safely and reliably, which is how we're going to do it from now on, unless I can find a better way. And you can see why, like, this is not a reference, this is like a thing on the C stack, so this can like appear and disappear. I thought the other ones weren't, but they obviously are, because during testing it's shown up that they can be moved. So I do get by name. So that's going to recover. So when our draw function, where is it? Whoa, all the way up here. When this draw gets called, it's going to say, okay, give me the draw field on this table, and it's going to say, nope, it's not there. So it's going to go to the meta table, and then it's going to the index meta method, and it's going to look it up, and this is going to end up being called, and we're going to call the index method, and we're going to recover the type info for what we want. But what we're expecting, let's just check what we're expecting, because when this gets called, we're expecting a user data on the stack, user datum, and that would be at I believe that's at the top of the stack. So if that isn't there, actually, yeah, that's the bottom of the stack, sorry. So yeah, the user datum is the first thing, is the bottom of the stack. You'd have to check the manual if you want to be really sure about what Lua is going to do with all these things. All right, just take the Lua's print stack function and print out the stack whenever you're debugging, and try and find out what you think is supposed to be there and what isn't. So we expected our user datum on the Lua stack. So we're gonna use these Lua errors to specify what's going on in, and conveniently we just have the type name now without having to mess about too much. So we're expecting the user datum to be on the bottom of the stack. We're also expecting at the other end of the stack to be the name of the field that it accessed. So in this case, it's the draw field. So I'm expecting that to be a string, not strong. So if there is no string as the last thing, what did we expect? I expected the name of our native property. So I'm just doing lots of error checking to hopefully help this go smoother if anything goes wrong. Native property, expected name of native property or method when indexing native type. So we're just checking that what's on the stack is what we're expecting. So you need to look up how the index meta method works if you're unsure, and check what you're expecting on the stack. But we need the name of the thing that it's trying to get out of the field, and we might not need the user data this time, but we need to know that it's there. So you could actually, if you were in a production environment, you might surround this with like define this out and say, oh, this only happens in debug code, because we don't need to do this in production because all the bugs are supposed to have been fixed by there. But I'm going to leave that in there for now. So we know that that string is there. So let's get that first, because we're going to need that. We're going to need that to be able to call our method. Now I'm not going to call it method name, I'm going to call it field name. And the reason is because later on I want this index function to also handle getting properties. So it'll be able to call methods but also get properties. So I'll just call it field name for now, because this could be one of the properties that we're accessing, like X and Y, but it also could be the draw or move function. So once we've got the field name, we have the type info, we should be able to get that method. So we can now recover the method that we think we were trying to call. So that's that field name. So that's an RTTR method. I'll just call it M for now. And again, this is well, I'll get to this later, but we need to check that this is a valid method. If it's not, then one of two things has happened. Either, well, somebody might have messed up their script because they've spelt the name wrong, or perhaps this isn't a method at all. It might be one of the properties that is on this on this type that we're indexing. So we might want to check that that's valid, and if it's not, we might want to do something else, but we'll get to that later on. We're not going to do that in this video. So we've now got our method that we want to invoke when we're calling the index function. And the first thing you might think is, and this is what I thought originally what I could do, is I can now call invoke on this method. So, and it needs this time it needs an instance object. We've called this before, but only on like 3 functions, but this needs the instance object. And we've got that because we've got the user data here. Well, we know that it's at this point. So let's just try that, and we'll see why this doesn't work. Because this might be your first port of call for thinking, oh, I know what I do here. And this is an RTT. Remember, all our user datums are RTTR variants. So I'm just going to cast it straight into one of those. And this is our user datum that we've recovered. So we can pass that in. That is the instance object. So there you go. So we can check that we can get the method that we've recovered, and then we can invoke it. So this, well, again, this doesn't handle like return types and parameters and all that kind of stuff. But you might think, cool, this is the way to go. So let's see if we can even get that far. Type RTTR variant. Why is that wrong? What's wrong with that? Conversion from int to RTTR. Oh, it is user data. It's to user data I want. Well, at least the compiler caught that. That would have been a right mess if that had gone to runtime. Right. So hopefully this should be getting called, I think. Let's try it. Let's see what we get. So here's our automated binding script, hello world 3. And there you go. That, if you remember, our draw function, I'll show you. Our draw function is actually just printing out the position of the sprite. So that's our equivalent of a draw function. And it's actually working. So it's actually invoked the draw function on our sprite, which seems to be correct. But it then says, attempt to call a nil value method draw. So it's worked, but then it's failed afterwards. And the problem is that when we invoke using the syntax in Lua, where is it? And when we call a sprite draw, what we're doing is we're going to the index meta method in the meta table and saying, find me the draw, and then invoke this function on it. But what we're doing is we're going in, we're finding the draw, invoking the function ourselves, and then we're returning a nil. So when Lua comes out, it goes, okay, now I'm going to invoke this function, and the function's nil, so it crashes at that point. So to be able to do this successfully, we actually have to return a function here when we're using this method. We need this to not actually call a function, but actually return a function here. So we actually don't want to call that. We actually don't want to invoke here. We want to return a function on the stack that Lua can call. So the easy way to do that, let's say, so we've got to return 1 there. We need to return one function. Let's just return another C function that can handle all the calls to the methods. Push C closure. So let's call this invoke function. Let's call it invoke func on user data. And I'm going to give it one up value, which we'll decide what that is now. So we're giving it a function to invoke, so it's going to return this function on the stack, and then we can call that. So how do we know what to call? Well, we can pass as an up value this method, which is, now we know we've already done the hard work of finding out the method we want to call. So let's pass this as an up value to this new function, this C closure, and then we'll just have a single function on its own that can just call that method. The problem again we've got, and this is the problem I was talking about with the bug previously, this method is just on the C stack. So if I push an up value to it, there's no guarantee it will be there by the time the function gets invoked. So what I'm actually going to have to do is I'm going to have to put it into a user data. Because remember, a user data is a piece of memory that's managed by Lua. So if I put that on as an up value, I know that's going to be there at the time the function gets called. So I need a user datum that's big enough to fit that method in. And that's the method user data. So I'm going to use this as my up value. And I need to remember, I need to placement new. I need to placement new this RTTR, call the constructor on it. And I'm going to copy in the method m that I've got on the stack there, this one here. So I'm taking a copy of that and I'm giving it to Lua, so that by the time this method gets called, it's not gone wrong or anything like that. Let's just I'll leave that there for now, actually, that comment. So that's going to return as a function with an up value that is the method to call. So that's actually kind of what we want. We've now got another function we need to make that knows more information. It's more precise now. It's just call this method and call it with the user data. Because remember, when Lua calls this function, the draw one, it's going to pass the sprite as the first parameter, because that's what this syntax does. This colon syntax means this sprite's actually going to get passed in here. So we're going to have the user data, and we're going to know the method, the native method we want to call, and it's all going to be there for us. So let's create that function, and let's see if we can get a little bit further into what we need. So this is turning out to be a slightly longer tutorial than the others at the moment. I'm trying to keep these short, but I'm not going to do everything we need to do in this one to get this all working yet. But we're going to do enough to at least see that we can have maybe called a function. So this should now get invoked whenever the draw happens. So and it should have a user data that is actually the method we want to call as an up value. So let's recover the up value first. So it's to user data, and it's Lua up value index. I'm going to just completely recover that as our method. So we've kind of done what we had before down here. We had our method there that we wanted to invoke, but instead of invoking it, we're actually going to push on a closure and we're going to pass in the method that we want to invoke. So it seems a bit around the house, but we need to do this because Lua is expecting us to return a function with that syntax. So we've got to return a function. So that was our method, and we've recovered it there as an up value. So again, we can do the same thing we did in this one here, which we'll copy a bit of this code. We're expecting the same user datum to be on the stack of that index, except we're not indexing a native type now. We're invoking, invoking method, and well, we'll say native method so we know what it is. Because we kind of like this function is now a little bit more precise than it was before. Oops, that's not what we want. So if that user data isn't there, then we've got a problem. And we also, what do we need to do? We need to recover that user datum now so we can invoke the method. Because remember, what we had down here was the invoke, but actually what we want to do is take that and we want to put it in here. So we want to invoke that, but as you can see, now we need to recover the user datum as well, which is the object we're calling on. So let's get that back as well. And that is the thing, that's just on the bottom of the stack. I think Lua's passed us that on the bottom of the stack. Yeah, so we've asserted that there. It will get an error if that didn't work. And that is always an RTTR variant. So wait for it. So hopefully that is enough information to just do a basic invoke on that. But let's also do one more thing which our runtime type library requires. Well, it doesn't require, but you get a variant back as the result, and if this variant is invalid, then something went wrong with your call. So let's also check that. I'll just copy this error. So this is failed to invoke native method, and that's correct there, I think. So that'll give us an error if something went wrong. So hopefully let's just check that compiles before we go any further. Initialized but not referenced. Oh, so you can see here now we didn't actually need in this index function, we didn't actually need the user datum anymore. We didn't actually use it because all we were doing was recovering the method and then pushing on. Now it may be that we use this at some point later on, but at the moment we're not using that there. We are using it when we invoke the function. So let's see. So we seem to have that. So let's see if this actually works. And it looks like it has. So it looks like it's invoked our sprite draw function, and it's drawn the X and Y 0 on that particular sprite that we've created. So that's been reasonably successful. But of course, this is, I mean, we'll just go through it one more time. What we did was we created the index meta method on the meta table for each one of our types. And then what we did is when that draw gets invoked, we call sprite draw. When that gets invoked, it doesn't have a draw, so it's going to go to the index meta method, which we bound to this function. So that function, we knew the type name, and because we knew the type name, we recovered the type, and then we looked to see if that type had a method, which it did. So it obviously went in here, and then we passed the method through to we set it as an up value on a C closure, which we then returned from here, and then Lua called that C closure, and then immediately went in here. We recovered the method that we wanted to call, we checked all the things, and then we just called invoke, and we didn't pass any parameters, and all we did was check the return type. We didn't actually return any values. So that's what we're doing there. And obviously that you can see there's more work to do there because we haven't handled parameters and return types properly yet. But we'll do that in a future video. We've already done it previously on global functions. So we'll have to refactor our code, and we should be able to use the same code that we used on that to do the same thing here. So before I leave this, I really want to go back and fix that bug, or that potential bug waiting to happen, which is we pushed the address when we did our new function, which is create new user datum. This one here, where is it? Create. We actually pushed on an address here, and this is not safe code. So I want to change that now, and let's just, while we've got this code working, let's fix that. So we want to push in the type name instead of the actual address of the class to register. So I'll just change that. I'm changing out the address of class to register for the name of the class, basically. And then in that new function, when we create in this case, sprite, which is our only example, we want to do, where is it? We want to do the same thing we've done here, which is instead of getting the type address, we're going to get the string name of the type, and we're going to recover the type from that. So let's just copy that in there and do a little bit of bug fixing here. So the type to create is that. So that's just a little bit of bug fixing. So we're just doing a little bit of a tidy up. That should still work. So that's still good. We've basically fixed a bug there, where we fixed a bug that was waiting to happen, that we needed to invoke that type correctly. And before we leave, in our invoke function, we should probably put some to-dos in here because there's stuff that we haven't done. So what haven't we done in here? Let's see, let's put a to-do here. I'm going to put them in as errors, so we're going to leave this with a failing way. We need to pass parameters to native method. So we had a working program, and I've deliberately broken it now. That I've basically said here, we're not actually looking at the we're not actually passing the parameters through here. So we should get an error on this now. Yeah, so we're saying we need to pass parameters to native method draw. So that is something we've got to do in the future. We've also got to, let's put another one down here. Need to return values. We might do this in all one thing next, but from native method. So there's a to do there. And is there anything else we've got to do? Yes, there is. There is also one more thing, and I mentioned this before. When we go in this index user datum function, we check to see if we got a method, and if it's valid, yeah, we go in for the method. But if it's not, it might be a property. So we need to check to see if is a property of this. So we need to check to see if field name is a property of type name, because it could be that we're just doing are we just asking to read the value of X there? So basically that should still be failing. So there you go. So that's the way we've left it. We've left it that we're able to call functions, but we've left it with a to-do that's basically breaking it for us. and possibly another one after that. So that's, you can already see we've got our work cut out for the next few videos, is that we need to get this working, we need to get properties working, and then we need to get the new index version of this working where we can write values as well. And then we're on our way to being able to like really use this in like mapping a lot of other types and then using them from Lua. So we'll do that next time.